Hello. In this video you will learn how to drive your own high voltage PMSM motors. It means permanent magnet synchronous motors or three-phase brushless AC motors. In the first step you will understand how to configure your own RX23T kit in order to manage this high voltage motor. Basically, we'll see that the power stage is quite easy to manage and the inverter kit is easy to plug and configure to drive your own motor. The second step is how to use the auto-tuning process, which is automatically embedded in the RX23T software. And you will understand that using the PC GUI, you can manage to extract the intrinsic motor parameter without using any expensive tools or any oscilloscope. Finally, you understand how to fine-tune the algorithm to have in between your hands a ready-to-use prototype. But let's first have a look about the targeted permanent magnet motors we have in our hand. This is a 200 volt and 200 volt motor basically. The nominal speed is 4000 RPM. The maximum speed of this motor is rated to 16,000 RPM, 16,700, which is basically using field weakening algorithm. And finally, the maximum power is about 800 watt and the maximum current peak is 6 ampere. We will see that we could manage to drive this at 4 to 5 ampere. Which step are we going to follow? First, we will prepare together the materials that you need. Second, we will set up together the RX23T embedded software. We will set up the hardware itself, the MCU kit basically. We will set up the complete safety and the connection of the power stage, the rectifier and the MCU board. And finally, we will run together the auto calibration and fine-tune the PC GUI software and the complete system. First, let's prepare the materials. Bring your own motor, get the motor control RX23T kits, get the power stage, which is 1.5 kilowatt at 230 volt AC. We need also a power supply. The 24 volt is good enough. A rectifier to rectify the mains and to generate the 300 volt DC needed by the power stage. The E1 debugger is needed, of course, and finally, in terms of hardware, we need also a transformer, an installation transformer to ensure the highest safety. And in terms of software, you need to have installed on your PC Z-Square Studio and the motor control demo GUI that you can download of the Renesas website, www.renesas.eu/motorcontrol. And you will also download the complete embedded software running on the RX23T called Y-Rotated RX23T_v1.zip. But let's start by setting up the RX23T embedded software. The first step is basically to connect the power supply to the board using the USB cable. So the board is basically powered with the USB. And after that, to connect the E1 debugger directly onto the board and check the status of the LED. After that, you basically need to launch the Z-Square Studio. We will import the software into Z-Square Studio. I just stored it on the desktop. And I would like to ask you to open the source folder and open the customers.h file. Very important file. and uncomment the line 49 in order to enable and activate the use of the power stage. Now you can build a project, which takes a few minutes, with the new configuration. It will enable you to connect an external power stage, and after that you can run the debugger, debug configuration. If you go to the hardware one, the E1 debugger is already set up, and the RX23T also. You can check the LED on the debugger that they are blinking when you're downloading the program. The last step is to remove the E1 debugger. Let's configure together the hardware kit. There are a couple of jumpers like the GP1 and GP2 that needs to be moved to the position 1, 2, 3 on the left hand side, as shown on the video. The GP6 need to be set up on the first position, and the GP10 to GP16 needs to be removed. Now the kit is ready to manage the high voltage power stage. By removing the jumper, we will enable the connector to work correctly. So we first plug the power stage and the 24 volt power supply. We will plug directly the high voltage motor, only the 3-phase, fully sensorless. We can connect the PC through the fully isolated USB. And finally, we will connect the rectifier once the LED are working fine. Yeah. So the rectifier is directly connected to the power stage. Finally, the last step is to run the auto calibration and fine-tune the high voltage motor. It will be done in 3 steps. The first one is to run the intuitive PC GUI and to enter the known parameters like the speed, the maximum current. The second one will be to launch the automatic current PI tuning and to launch the motor identification process. And finally, to test the setup at different speeds and adapt the speed PI coefficients if it's required. So now we will launch the motor control demo. First by setting up the communication, the serial communication. We use a small FTDI chip to convert the serial link to USB. First we launch the speed control window to check we have 300 volt, 320 volt. After that we will set up all the parameters of the applications. The minimum speed, we will set it up to 200, maximum speed 4000, acceleration ramp and deceleration ramps to 1000 RPM per second. Maximum current, we will set it up to high, to 3 ampere and 5 ampere for the maximum current. And we will set the 5 parameter to 0, the 5 parameter that we will find automatically. We save it and we close. The first process is the auto-tuning for the KPKI of the PI controller. We found 2 values and let's test it by applying a voltage step. I reduce a little bit the current we apply just to check we have a perfect response on this. So the value we found are perfect, so let's move on to the second step, the motor identification, to find out RS, LS and FL. So stator resistance, synchronous inductance and flux permanent magnet. During this phase the motor should be able to run yeah, we found 3 values that we can accept, and let's check in the parameter list. Everything is okay. Let's start by providing in the speed control small speed reference, 250 RPM, so we can see we have a small overshoot on the speed, but the motor is running at this stage. It's a very good sign. We have also in the oscilloscope window the possibility to check the phase and the current of the motor. We can see it's not very stable, so that's why we will play a little bit with the kpk coefficient for the speed controller. I will start by increasing it to 100. We can see that it's not really stable at this stage, so I will keep on working on this. Where are we at the moment? Yeah, 100. I will try with 150. And I will come back to 50 just to check if we have a better response. Yeah, at least a better phase. Yeah, I will do such kind of manual tuning only for the kpk for the speed controller. We can see that the motor is still running fine. The phase seems to be better now. The current is very low because this is without any load. So now we can try to increase the speed, 300 RPM for example. The next step is to increase the maximum speed, so we will set it to 10,000 RPM just to test also if the flux weakening algorithm is working fine. So we still have 320 volts. I will start by giving 500 RPM and check how it's running. 1000 RPM, 2000, so the motor is running really fine and smoothly. Yeah, 6. So 6000 RPM on this. 7000, working okay. 8000. We can see on the oscilloscope the current is really getting higher because there is some direct current which is added to the torque current. So in fact the total current is increasing over 1 ampere, something like this. Yeah, 8700. The flux weakening is really working fine at this stage, and we can see that at 9000 and 10,000 it's even higher. Finally, a very nice feature in the PCU is that you can extract the parameter in a header file, which gives you the list of all the parameters that we tuned and got during the tuning and fine-tuning processes. So all this file can be imported into your project. Let's recap. With a minimum amount of materials, within 15 minutes you can run your high voltage brushless motor at low and high speed. The auto-tuning system running on the RX23T enables you to drive your own brushless motor very quickly. So get your own kit on www.renesasshops.com, and finally download all the material of the kit on renesas.eu/motor control. Thank you very much. Bye bye.